Today's lesson is the first lesson in the Systems of Equations unit. This first lesson will be mostly review, how to solve systems. We have 3 different methods for solving systems. We can solve by substitution, we can solve by elimination, or we can solve by graphing. Our first method that we're going to talk about today is substitution. If you think about the word substitute, it means to take something out and put something else in. And sometimes people in this method, they forget to take out what they need to take out. So make sure you're taking things out when you do this method. If we look at these 2 examples, the difference between the 2 is this one of the equations is solved for y and the other one is not. Whereas on example B, these are both solved for y. And so our method for how to work them is a little bit different. On example A, what I'm going to do, since this is already solved for y, I'm going to take the 2x plus 10 and I'm going to plug it in for y. Now remember, when I plug it in, that means you take out the y and you put in whatever else you're going to put in. So I'm going to take out my y and I'm going to put in the 2x plus 10. Then when I put that in, I'm going to solve this equation from here. So I'll go ahead and combine my like terms. That gives me a negative 2x plus 10. And then I'm just going to finish solving this out. So I'm going to subtract my 10 from both sides. And I will divide by negative 2. And I get x equals 9. Now, that's step 1. Each of these has a 2-step process. And so step 1 is we have found x equals 9. Now we need to go on to step 2, and I also might warn you that you might have to write kind of small today. Step 2 is to take that x and plug it back in and find y. Technically, you can use either equation. If you look at these 2 equations, I think you might see that one is easier to use than the other. I'm going to choose the bottom one. And the reason I'm choosing that bottom one is because it's already solved for y. And so when I work it out, it's just going to be already solved for y. I already have my answer. And so that's just going to make it easier. So this is going to give me y equals 28. And so my final answer here is 9/28. And let's think about what that means. What that means is if you graphed these 2 lines, they would intersect at the point 9/28. Now you might think, well, why don't we do that? Maybe we could graph those. That's true. Maybe you could graph them, but a lot of times the graphs that we have don't go all the way up to 28. And so it's helpful to have a different method to do it. So this is a different method. Of course, we would want to check these. And because I'm a little bit limited on space, I'm going to do a mental check. So y is 28, so I get 28 minus 4 times 9. That's 36. 28 minus 36 is negative 8. Yes, 28 minus 36 is negative 8. And it should definitely work in here because I just did it over here, but I'll check it in case. 2 times 9 is 18. 18 plus 10 is 28. That works. So that is how you solve when the equations, one of them is already solved for y, the other one is not. Example B is very similar, and I say that there's a different way of solving it, but really it's the same thing, because really what we're doing is we're taking this value and we are plugging it in for that one. So I'm going to take out my y and I'm going to plug in this negative 3x plus 4. And so really it's the same process as this. The reason I start off by saying it's a little bit different is because another way to express that, another way to say that, is you set them equal to each other. Since they both equal y, then these 2 parts equal each other. And so that's just another way of saying it. I'm going to subtract my 2x over here. I'm going to subtract my 4 to the other side. And now some of you are not going to like this because my answer comes out to be a fraction. Well, guess what? A lot of times that we do problems and we do math, we get fractions. So that's not unusual. There's my x value. Remember, that was step 1. We came up with our x value of 2/5. We now need to plug that into one of the other equations. You can choose either equation. So my step 2 is to plug it in. I personally am going to use the top equation because it doesn't have any negatives in it. A lot of times people make mistakes with negatives, myself included, so I'm going to go ahead and avoid that by using the positives. So now when I multiply this, 2 times 2/5 is 4/5, and another way to say 2 is 10/5. And so if I add 10/5 plus 4/5, I get 14/5. So my final answer is the point 2/5 and 14/5. Now again, could we have graphed these and found the intersection point? Yes, we could have graphed them. But if they intersected at this point, that would be pretty hard to tell the exact answer for. So we went ahead and solved it because this way we know what the exact answer is. I am going to go ahead and double check my answer. I like to check my solution. And so I want to do that, especially because it's fractions. I'm going to choose the bottom one to check with because I just did that top equation here. So if I go back to my bottom equation, I have a -3 times my x was 2/5 and plus 4, and another way to say 4 is 20/5. So that's a -6/5 plus 20/5. -6 plus 20 is 14/5, so this answer does work out. So both of these methods are very, very similar. Both of them, you want to check your answer to make sure you're doing it correctly. That is solving by substitution. Let's talk about solving by elimination. A lot of people, after they do all this work for substitution, they think this is a really long process. And I agree, it is. Elimination seems much easier. The deal with elimination is you need to get either your A's to match up or your B's to match up. And when I say match up, what I mean is they have to have the same value but opposite signs. So either the A's or the B's. So like you could have a -5 and a +5, something like that. Because then when you add them together, they'll drop off. Elimination means drop off. So I need to look at these and I need to decide how could I make them drop off. I think the easiest way right here is with this 6 and -2. That is, I'm going to multiply this bottom equation times 3. And when I do that, I have to multiply all 3 parts times 3. So that's going to give me a -15x minus 6y is going to be equal to -42. I'm going to go ahead and bring my top one over here just so that I have them on top of each other, because that way I can see how they're going to line up. Do you see how they're lining up with that 6y and the -6y? That's good. That's what we want. So now when we add these, this gives us a -12x. This one drops off. That's what we want. It's called elimination. And we get a -48 over here. And now I can see that I divide by -12, I get x equals 4. So I have my x value. Of course, this is a 2-step process, so my second step is to solve for the y value. You can choose either one. I'm going to choose the top one because I like to avoid those negatives, so I'm going to choose the top one. 3 times 4 plus 6y is equal to -6. And now I'm just going to simplify this. So that's 12 plus 6y equals -6. If I subtract my 12 from both sides, I get a -18. And so that's going to give me y is -3. So my solution on this one is 4, -3. That one, if we graphed it, that would be really easy to see the intersection point. I might just check it real quick. I might check it in this bottom one. -20 plus 6 is -14. It does work. Example B is really very similar, so I might just save example B for class tomorrow. We can maybe do this one as a warm-up. So think about example B and how you might do that as a warm-up. Okay, why do we have so many methods? Well, because they all work, and it's just a matter of which one you like better, and also when is one easier than the other. And so even though maybe you don't like substitution because it just looks like a lot of work, sometimes it's easier. And the time that it's easier is when the y is already isolated. And we should say, I guess, or the x, that it can be solved for x and you plug in the x. That works also. Well, when is the elimination method easier? That's easier when both systems are already in the same form. Really any of the form, but really standard form is the most common. So if they're both in standard form, they're very easy to drop off, make one drop off. Okay, what about no solution and many solution? Because we do have those that come up. When does that happen? Well, if you're working it out and solving it, when you do that, the answer will be something like 5 equals 8. If you get 5 equals 8, that means no solution. Of course, it's anything. It could be 0 equals 2. It could be 10 equals 20, whatever. Something that doesn't work, that means no solution. The graph of that would be 2 parallel lines, because we've been talking about how each of these up above here, when they hit, that point is their intersection point. Well, if they're never hitting each other, then they're going to be parallel lines, and that's going to be no solution, okay? That's when there is no solution. What about the other situation, when you have infinite solutions? What would that look like? Well, when you solve it, you get something like 5 equals 5. That means that it is infinite solutions. What would it look like on the graph? It means that you graph one of them, and then you go to graph the other one, and it's exactly the same line. And so the solutions we're talking about here is a little bit different. It's not all real numbers, because it's not all numbers that would work. It's only the numbers along this line, which is there are infinite points along here, but the ones out here wouldn't work. The ones out here wouldn't work, only the ones on that line. So there are infinite number of them, but they're a specific set. Let's go ahead and turn the page. All right, how about graphing these? What does that look like when we graph them? In Algebra 1 and maybe even geometry, you did this where you graphed the two lines, you find out where they intersect. I'm going to add a little bit to that. We're going to do 3 of them, and we are going to find the vertices, okay? So let's take a look at how to do this. You might choose different colors to do this. You don't have to, but sometimes when I introduce this, I think it's easier sometimes to do different colors. This top line, I'm going to call it L1. It's the top line. It's the first line. It is x is less than or equal to 6. That line is going to be right here. It is solid because it has an equals to, and it is less than. Some people, when they do this on the shading, they just like to draw a little arrow, and you can do that if you want, or you can just shade the whole thing. I don't care which way you do it. In the end, I do need to be able to see which part is shaded. Okay, that's L1. Let's go to L2. L2 is going to start at 1 and is going to go up 1, right 2, up 1, right 2, up 1, right 2. And I'm going to need to connect these points. If you have a ruler, I would recommend using it. I'm going to use my straight edge tool because my lines just get kind of off. So I'm going to go ahead and use that tool. So when I connect these, once again, it is a straight line because, it is a solid line because it has the equal to with it. And we need to decide which way to shade. So as you look at which way to shade this, do you know which way to go? Well, it says less than. Less than means below. So I'm going to shade this one below. Now, I do not need to shade over here. I already know this is not part of my solution. I'm just going to shade in this area. And again, if you just want to draw your little tiny arrows, you can. But that's the part that's shaded. Now, I'm looking for all 3 lines. So I'm going to label this one. This is L2. And I'm going to label this one as L1 so I don't forget which one is which. But now I'm going to go to L3. L3 starts at 4, goes down 2, right 1, down 2, right 1, down 2, right 1, etc., etc. And we can go the opposite way also. And once again, because I don't have a ruler, I'm going to use my tool here, but you should use a ruler so that you have that. Okay, here is my line. And now I need to decide again which way to shade it. So I'm going to look at my equation. My equation says greater than. Greater than means above. So I'm going to go above and shade above the line. I only need the part where all three colors come together. So I am only going to color in this section because that's where all three of them meet. I don't need to go to the right side, I already talked about that, but I also don't need to go up here because there's no green up here. I really only need this triangle. This is my answer. That's how you graph it. However, the other part of the question was to find the vertices. So I need to find out where is this point, where is this point, and where is this point. And if I use my straight edge, then some of these will be easy to see. This one, I did use my straight edge, but my straight edge didn't totally go through my correct points, did it? I'm going to cheat and move this up a little bit because it needs to be moved up just a little bit. Because the reason I knew that is there was a big fat green dot there, and I knew that big fat green dot needed to be moved up a little bit. Okay, so that is one of my intersection points. That intersection is at 6, 4. It's helpful that I labeled my L1 and L2 because that means that 6, 4 should work in L1 and it should work in L2. And I know these are less than signs, but the lines themselves are the equal to part of it. So if I plug this in, does 6 equal 6? Well, yes, it does. And if I plug it into L2, then I plug in my 6 here. Half of 6 is 3. 3 plus 1 is 4. That is correct. All right, down here, I'm looking at this, and once again, my red line is pretty far off. I didn't use my straight edge on that one. Should have used the straight edge. But do you see again how there's that big fat blue dot there? Well, that big fat blue dot should be an intersection point. That dot is at 6 and -8. And this line here is L3. And so this is the intersection of L3 and L1. So the 6 obviously does work for L1. Let's talk about L3. If I plug in a 6, I get -12 plus 8. That's -8. That does work. All right, those were easy. Here's the hard part. This point right here, I cannot see where it hits. And in fact, it's not just because I was messy, it's because it hits at a fraction. And you might think, well, can't we just estimate? Not really. We need to have an actual answer for this. How are we going to find that answer? Well, I've lined up this one as L3, this line is L2, so I need to come over here and look at L2 and L3 and basically find those intersection points. If I look at the equations, they're both set up as y equals. And again, I know there's a less than and a greater than, but the line itself is the equals part. So I can set 1/2 x plus 1 equal to -2x plus 4. And that's going to tell me what that crazy intersection point is. So I'm going to do my math here. I'm going to add 2 to both sides. That gives me 2.5. Well, 2.5 as a fraction is 5/2. I'm going to subtract my 1 the other way, and I get 3. And so now I need to solve for x, so I need to multiply both sides by 2/5. And so I get x equals 6/5. Okay, let's look at that. That's like 1 1/5. If I come over here, 1 1/5, yeah, kind of. That's pretty close, isn't it? So 1 1/5 seems like a reasonable answer. Now, remember we have to go to step 2. Step 2 is plugging it back in and finding y. It does not matter which one we use. Well, look, the bottom one doesn't have a fraction. I say we choose that one. So we have a negative 2 times 6/5 plus 4. And notice again, I'm using the equals because the line is the equals. So it's okay to use that equals. All right, I get y equals negative 12/5 plus 4. Well, 4 is 20 over 5. And so that is 8 over 5. Sorry, that's messy there. 8 over 5. So, as we look at this answer, our answer should be 6/5 and 8/5. Let's double check that again. 8/5 is like 1 3/5, and that's the y value. Yeah, that looks pretty close. So I'm going to say my answer is 6/5 and 8/5 for my third intersection point. I guess I should draw it over here, but that is my third intersection point. You would want to check it. I just did it in this one, so we have to do it in that one. 1/2 of 6/5 is 3/5. 3/5 plus 5/5 is 8/5. This one does work. So all three of those works. I have my 3 vertices. There is one more example on the page, but I think again we will do that as a warm-up tomorrow.